Hi everybody, it's now time to discuss questions over areas related to circles. Let's begin with the first one. The radii of two circles is given to be as 8 centimeters and 6 centimeters. So let's take R1 as 8 centimeters and take R2 as 6 centimeters. Find the radius of the circle having area equal to the sum of the areas of these two circles. So let R be the radius of third circle. This is the radius of first circle, say C1. This is the area of second circle, say C2, and let R be the radius of the third circle such that area of the third circle is equal to sum of the areas of the previous two circles. So area of the third circle is pi r square is equal to sum of the areas of these two circles, which is pi r1 square plus pi r2 square, which is pi 8 square plus pi 6 square. So you have pi r square is equals to pi 64 plus 36, which is 100. Pi cancels out, you have r square equals 100, which means r is plus minus 10, but radius is always non-negative. Radius is the distance between center and any point on the circle. The distance can never be negative. So this implies r is plus 10 centimeters. So the radius of the circle such that its area is equal to sum of the areas of two circles having radius 8 and 6 has to be 10. Next question says that take the correct answer in the following and justify your choice. If the perimeter and area of a circle are numerically equal, then the radius of that circle will be equal to what? So there is a circle whose perimeter and area, which means circumference and area, is equal. So circumference is 2 pi r. Let the radius of the circle be r centimeters, then its circumference will be 2 pi r, or the perimeter will be 2 pi r, and area will be pi r square. Let r be the radius of that circle whose circumference is equal to the area. 2 pi will be cancelled out, 1 r will be cancelled out, you will be left with r equals 2 centimeters. Fine. So only and only it is the very circle of radius 2 centimeters for which the circumference is equal to the area. That's a very nice question and observation as well. Then it says the length of the minute hand. So obviously let's go back to the second question again. You will be ticking option number A, and justification is this. So you have the next question, that the length of the minute hand and of a clock is 14 centimeters. Find the area swept by the minute hand in 5 minutes. Now 5 minutes, you have to understand the situation. If that's the clock, say this is 12, this is 1, this is 2, and so on. Okay, so this is the center. Say right now my minute hand is here. After 5 minutes my minute hand will be here. Right? Let's just take 12 and 1. You can take any two consecutive digits. Between any two consecutive digits, you know there is 5 minutes gap. So right now my minute hand is here. After 5 minutes it will be here. So how much area would it be sweeping? This is what? What is this? It's given that the length of the minute hand is 14 centimeters. So the length of the minute hand is 14 centimeters. Okay, so this is 14 centimeters. You can clearly identify that right now this is nothing but the sector of a circle of radius 14 centimeters. So if this point I take as A, this point I take as B, and center as O, then area of sector AOB is what I have to find. Is it clear? Area of AOB is what I have to find, which is the area which is swiped by the minute hand in 5 minutes if it is having its length as 14 centimeters. Now area of sector AOB I am able to find only when I know the angle of this sector, which is this, right? Now if I talk about angle at a point, It is 360 degrees. That means right now my minute hand is here. When it completes one revolution, the angle swiped is 360 degrees. That means in 60 minutes, in 5 minutes it will come from 12 to 1, in another 5 minutes it will go from 1 to 2, in another 5 minutes it will go from 2 to 3, and so on. When it will be covering 60 minutes, it would have rotated by 360 degrees. So in 60 minutes, the minute hand rotates by 360 degrees. So in 1 minute, minute hand will rotate by 360 upon 60 degrees, and therefore in 5 minutes, minute hand will rotate by 360 upon 60 into 5, which is 30 degrees, and therefore the angle is 30 degrees. So you just need to find the area of this sector having angle 30 degrees, and it is a sector of the circle of radius 14 centimeters. So it will be theta by 360 into pi r square, that is 14 into 14. This, whatever this comes out, centimeter square, is the area swiped by the minute hand in 5 minutes having its length as 14 centimeters. Is it clear? You can easily compute this. That's your drill. Next question says that from each corner of a square of side 4 centimeters, a quadrant of a circle of radius 1 centimeter is cut out. So you can see this is a quadrant of a circle of radius 1 centimeter. That means this much distance is 1 centimeter. This is also 1 centimeter. Same is the status with the rest of the quadrants as well, because from each corner a quadrant of 1 centimeter of a circle of radius 1 centimeter is cut out. If this is a quadrant, this is a right angle, this is also right angle, this is also right angle, this is also right angle. Clear? Also a circle of diameter 2 centimeter is cut out. This is a circle of diameter 2 centimeter. If this circle has diameter 2 centimeters, say this is the center, the radius of this circle will again be 1 centimeters. If the diameter is 2 centimeters, radius will be 1 centimeter, right? I have to find the area of the remaining portion. This is very, very easy. I will find out the area of this circle. I will find out the area of each quadrant. So I will have area of the circle plus area of quadrant 1 plus area of quadrant 2 plus area of quadrant 3 plus area of quadrant 4. And from the area of square, I will remove or subtract this sum of these 5 areas. I will be getting the area of the remaining part. So what I am trying to say is, area of the square you evaluate, from it you remove, I am saying this circle is circle 1, this circle of radius 1 centimeter is circle 1, you remove area of circle 1 plus area of quadrant 1 plus area of quadrant 2 plus area of quadrant 3 plus area of quadrant 4. So you add the area of all the 4 quadrants to the area of circle, and you remove all these areas from area of the square, you will be getting the area of this left out part. What is the area of the square? It is side square. Side is of length 4 centimeters, so 4 square. Remove from it area of circle 1. Area of this circle is pi r square, radius is 1 centimeter, so pi r square. Then area of the first quadrant plus area of second quadrant plus area of third quadrant plus area of fourth quadrant. Area of a quadrant of a circle of radius 1 centimeter is given by 1/4 of area of that circle. So 1/4 of pi r square with r equals 1 is going to be the area of this quadrant, and this also, and this also, and this also, because all 4 are quadrants of the same circle of radius 1 centimeter. So this will have area as 1/4 of pi r square, This also will have 1/4 of pi r square, 1/4 of pi r square, 1/4 of pi r square, and in each case r will be equal to 1. So I will have 1/4 of pi r square being added with itself 4 times. So I will have 4 times of 1/4 of pi r square. Pi is 22 by 7, radius is 1. Okay, so 4 times 1/4 of pi r square. This is the area of the sum of the areas of all the 4 quadrants. This is the area of the circle. You add, you get the area of this, all the cutout parts. Fine. From the area of the square, you remove the area of these cutout parts, you get the area of the shaded part. So you can solve this. This much centimeter square is going to be your required area. Is it clear? Let's move to the next question. Find the area of the segment. So there is this segment given AYB. Find the area of the segment AYB. This is the segment, the shaded portion. Find the area of the segment AYB shown in the figure if radius of the circle is 21 centimeters and angle AOB is 120 degrees. So obviously this is pretty simple. This is the center. You need to find the area of this segment. If from the area of this complete sector AOBYA, from the area of this complete sector, I remove the area of the triangle AOB, I will be left with the area of this segment. So area of, realize this, area of segment AYB is equal to area of sector AOBYA minus area of triangle AOB. Fine. What is the area of sector? It is theta by 360 into pi r square. Theta is given to you as 120 degrees as the angle of this sector. Radius is given as 21 centimeters. So it will be theta by 360 into pi into radius square. This is the area of the sector. What is the area of the triangle AOB? It is half into base into height. Height would be what? From the origin, or I should say from the center O, drop a perpendicular on side AB. Drop a perpendicular on side AB, let this point be M. When you drop a perpendicular on side AB, length of this perpendicular is the height of this triangle and AB's length is the base of this triangle. So half into base into height. This is the area. We are just left to compute the value of AB and OM, right? Now please try to recall this. Perpendicular from the center to the chord bisects the chord. AB actually is a chord of this circle and OM is a perpendicular drawn from the center to this chord. So it will be bisecting this chord. AM will be equal to MB. The moment AM is equal to MB, I know AB is AM plus MB. So if it is AM plus MB, I can write this as AM plus AM because MB is same as AM. So twice of AM is my AB. Clear? AB is twice of AM. Now focus upon this. This you can see is a right angled triangle. AOM is a right angled triangle. If you look at AOM carefully, this is a right angled triangle. Focus on these two triangles AOM and BOM. OA is equal to OB because it is the radius. OM is equal to OM because it is the common side. And AM is equals to MB again because of the fact that the perpendicular from the center to the chord bisects the chord. So by SSS congruence condition, both these triangles are congruent. So their corresponding paths will be equal. This angle will be equal to this angle. If this angle will be equal to this angle, but this complete angle is 120, each is half of 120, this much is 60, this much will also be 60. Have you understood this? I said AO is equal to OB, then you have OM is equal to OM, and then you have AM is equal to BM. So by SSS congruence condition, what is it that you have? The triangle AOM is congruent to triangle BOM. So this means that their corresponding paths are going to be equal. So angle AOM will be equal to angle BOM, but angle AOM plus angle BOM is angle AOB, which is 120, but BOM is same as AOM. So angle AOM plus angle AOM is 120, which means twice of angle AOM is 120. So angle AOM will be 120 upon 2, which is 60, but AOM is same as angle BOM. So both these angles will be 60, which is half of 120. Now focus upon this triangle AOM. In this triangle, this is a right angle triangle, right angled at M. I can talk about sine 60 and cos 60. What will that be? Let's talk about them. Cos 60, which is actually 1 by 2. Cosine is base upon hypotenuse. In AOM triangle, OM is the base, hypotenuse is AO. So you will have OM upon AO. OM upon AO. AO is 21 centimeters. So you have 21 by 2 is OM. Clear? Next, let's talk about sine 60 in that triangle. This is actually equal to root 3 by 2, but it is equal to perpendicular upon hypotenuse. So if this is 60 degrees, perpendicular is AM, hypotenuse is AO. So AM upon AO. Again, AO is 21 centimeters. So AM is 21 root 3 by 2 is AM. Twice of AM is AB. So AB is twice of 21 root 3 by 2, which is 21 root 3 centimeters. So you have the value of OM with you, you have the value of AB with you, just plug it in here. You have minus half of AB. AB is 21 root 3 and OM is 21 by 2. This happens to be, when you resolve this, when you resolve this completely, this much centimeters square is your required area. From the area of the sector, I have removed the area of this triangle. Let's talk about the next question. If a circle of radius 21 centimeters, in a circle of radius 21 centimeters, an arc subtends an angle of 60 degrees. At the center, find the length of the arc, area of the sector, area of the segment. So you have a circle in which there is an arc which is subtending an angle of 60 degrees. So say this is A, this is B, and actually it is the AB arc which is subtending an angle of 60 degrees at the center of the circle, whose radius is given as 21 centimeters. So OA is 21, OB is 21. Find the length of this arc AB. You know that length of the arc is theta by 360 upon 2 pi r, where theta is the angle which that arc subtends at the center of the circle and r is the radius of the circle. So length of the arc will be theta by 360 into 2 pi r. This much centimeters will be the length of this AB arc. Second, it says area of the sector formed by the arc. This is the area of the sector formed by the arc. What is the area? Area of AOB sector will be equal to theta by 360 into pi r square. Theta is 60 by 360 into pi into r square. This much centimeters square is the area of the sector AOB. Thirdly, area of the segment formed by the corresponding chord. So if I join A with B, this is chord AB, I have to find the area of this segment. Area of the segment is nothing but area of the sector minus area of this triangle. So area of the sector AOB let me mark a point Q over here, AQBO I should write, AQBO, this is the sector, AQBO, here also AQBO. From the area of this sector I remove the area of the triangle OAB and I get the area of the segment. Is it clear? This is the third part. What is the area of the sector? What is the area of the triangle? Area of the triangle is half into base into height. I don't know the base, I don't know the height. What will I do? See, OA is same as OB and angles opposite to equal sides are equal. So, if this angle is x, even this will be x. Angle at A will be equal to angle at B because angles opposite to equal sides are equal. By angle sum property, I can say 60 degrees plus x is 180 by angle sum property of this triangle. So, we will have 2x is equals to 180 minus 60 which is 120. So, x will be 60 degrees. So, this is also 60 degrees, this is also 60 degrees. A triangle in which each angle is of 60 degrees is an equilateral triangle, and equilateral triangle's area we can directly compute by the formula which is root 3 by 4 into side square. Side OA is of length 21 centimeters, OB is of length 21 centimeters, obviously AB will also be of length 21 centimeters only because it is an equilateral triangle. So, you will have root 3 by 4 into 21 square, where 21 is the length of any of the sides of the equilateral triangle because each side has same length. That is how you calculate the area of the triangle, and area of the sector you have already calculated in here. So, you will have 1 by 6 into 22 by 7 into 21 square. This is the area of the sector AQBO. From it you remove the area of the triangle which is root 3 by 4 into side square, and you get the area of the segment. Is it clear? You can easily compute this, and that is how you accomplish the solution of this question. Next question says that a horse is tied to a peg at one corner of a square grass field. Okay, so there is a square grass field and a horse is tied to one corner of that grass field. You can see that. It's a square grass field and each side is of 15 centimeters. So, each side is of actually 15 centimeters in this square field by the means of a 5-meter long rope. So, you can see the rope, this is there, this is of 5 meters, even this is meters, the unit is meters. Fine. Find the area of that part of the field in which the horse can graze. Now see, right now you can see that the rope is not at its maximum length. See, what is the length of a rope? It means when you straighten it up to the max, it is going to form a line segment, and that line segment is going to have measure as 5 meters. That means the horse can at the max stretch this rope to its maximum length of 5 meters. In that situation, whatever area it will be able to graze would be the max area it can graze in the field, right? That would be the max because this rope cannot be stretched or expanded any further. At the max you can expand it to its maximum length of 5 meters. So, in that situation, this is the rope. This is the rope. Right now, if it is like this and say this is the horse, it can graze in this portion. If it stretches it up to the max, it will be forming a straight line segment of 5 meter length. If the horse is stretching the rope up to the max, it will be forming a straight line segment of 5 meters, and in that situation the horse can graze in this much area. Of course, the boundary is of a square, so the moment I create boundary of a square, this actually turns into a quadrant, isn't it? The moment I consider the boundary of the square, this portion turns into a quadrant. So, this is the max area which the horse can graze in. It is nothing but area of sector of a circle of radius 5 meters and angle of sector is 90 degrees, right? So this angle will be 90 degrees because we are in a square. So obviously this angle is 90 degrees, and if you only consider this much portion, it is of a quadrant. So here you can see what is the maximum area in which the horse can graze in that square field. He will be able to gaze how much area when it is stretching the rope. When the horse is stretching the rope to its max, that is your 5 meters, then it is going to be able to graze the max area, right? That is the area which it can actually graze in. So it is nothing but a quadrant. So if I say this is A, this is O, this is B, and say some point here is Q, then AOBQ is the sector whose area is the answer of the first point. So it is theta by 360 into pi into r square. This much meter square is the area of that part of the field in which the horse can graze if it is tied to a rope of length 5 meters. What will be the increase in the grazing area if the rope was 10 meters long instead of 5 meters? If the rope would have been 10 meters long, then what would have been the area of the square field in which the horse can graze? It's very simple. If the rope would have been 10 meters long, then say this is the point to which the rope is tied. At the max, what the horse can do, it can stretch that rope to its max. In that case, the moment 10 meters length is done, this is where the horse is, right? So it can now graze in again a quadrant only. Again it can graze in a quadrant only, but this time in a quadrant of a circle of radius 10 meters. Instead of 5, 10 meters. So area in which horse can graze if length of rope is 10 meters is what? Again same, area of a quadrant of a circle of radius 10 meters, angle of the sector is, or angle of the quadrant you can say, quadrant you treat it as or a sector you treat it as, is the same thing, it is 90 degrees. So it is 90 by 360 into pi r square meter square. What is the increase in the area if I mark this as 2 and mark this as 1? When the rope was of length 5 meters, this is the area in which the horse can graze. When I increase the rope length, this is the area in which the horse can graze. So obviously when you increase the rope length, the area will increase. There is more area in which the horse can graze now because the rope will be stretched to a further more point, right? And therefore increase in the area is what? The answer that you obtain in 2 minus answer that you obtain in 1. This much meter square is the increase in the area. The increased area minus this area is going to give you the increase in the area when the rope length was increased from 5 to 10. Next question says that a brooch is made with silver wire in the form of a circle with diameter 35 millimeters. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors. So please try to see this. AB is the first diameter, CD is the next, EF is the third, GH is the fourth, and IJ is the fifth. And say this is the center of the circle, that is O. So AB, CD, EF, GH and IJ, these are 5 line segments which are the 5 diameters which are made, and each diameter is of length 35 mm. So diameter of the circle is 35 mm. That means what is the radius? It is 35 by 2 mm. So a brooch is made with silver wire. Now please see, with the help of that silver wire, I am making these 5 diameters. So I have used the wire in making these 5 segments, and I have used the wire in making the boundary of this circle. the boundary of this circle or the brooch basically, the boundary is nothing but the, how much wire can I say I have used in making the boundary? As much as is the circumference of the circle, right? So I am using that wire to make the boundary of this as well as to make these segments which are my 5 diameters. So if the question is find the total length of the wire used, then the wire has to be used to cover this up and to make these 5 diameters. That means what is the total length of the wire? It's saying that the wire is used in making 5 diameters which divide the circle into 10 equal sectors. You can count them. This is 1 sector, 2nd sector, 3rd sector, 4th sector, 5th, 6th, 7th, 8th, 9th and 10th. So these 5 diameters are actually dividing my circle into 10 sectors. How much wire do I need? I need wire to basically bind this over here. That is the circumference of the circle plus the 5 diameters. So how much wire do I need? 2 pi r, which is the circumference of the circle, plus length of AB diameter, length of CD diameter, length of EF diameter, length of GH diameter, length of IJ diameter. This much centimeters I need the length of the wire to cover this entirely, that is the boundary as well as the 5 diameters. That is 2 into pi into r, r is what? 35 by 2 plus length of the first diameter plus length of the second diameter plus length of the third diameter plus length of the fourth plus length of the fifth diameter. It's not cm, it is mm. But each diameter is of same length. So 5 times length of a diameter, diameter is of 35 mm length. This complete is the measurement of the circumference and the 5 diameters. So of this much measurement I need the silver wire so that I can make the 5 diameter as well as the boundary of this brooch. Clear? So the length of the wire required is this much mm. The area of each sector of the brooch is how much? Pick up any sector. Pick up any sector, each sector is of equal area. Each sector is of equal area. Pick up any sector. In order to get the area of a sector, you need the angle of that sector and the radius of the circle of whose it is a sector. So radius we already have because diameter we had, so radius is 35 by 2 mm. What is the angle? If I talk about angle at a point, it is completely 360, right? These are 10 equal sectors, right? So I can say like this, that this is x1, here it is x2, here it is x3, this angle is x4, this is x5, this is x6, this is x7, x8, x9, x10. But actually all these angles are going to be the same because they are equal sectors. So the angles are going to be equal. So actually they all will be equal to x only. So if this is x, then here also it is x, here also it is x, 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 x. So if I add x with itself 10 times, basically when I add the angles of all the sectors, I get 360 because angle at a point is 360. So I get x plus x plus x 10 times is 360. So 10x is 360. So x is 360 upon 10, which is 36 degrees. So each angle over here is of 36 degree measure. Each sector has angle 36 degree, and that is why I have the area of the sector as, any sector you can take, area of the sector as theta by 360 into pi r square, which is 35 by 2, again 35 by 2. This much mm square is the area of each sector. Fine, and if you multiply it with 10, because there are 10 sectors, you will be getting the area of this entire circle. The question was to find the area of one sector, each sector. This is the area of each sector. Is it clear? Next question says what? Let's see. In here when I am talking about the next question, so please first of all try to absorb this question very nicely. How have I actually understood that these are equal sectors and therefore they will be subtending equal angles at the center? Note this down, then we are going to move to the next question. Okay, so working towards the next question, it is saying that calculate the area of this designed region. Okay, calculate the area of this designed region in this figure common between two quadrants of a circle of radius 8 centimeters each. So let us just redraw it. It's a square. Find 8, 8, 8, 8. So each side is of 8 centimeters. It's a square, right? Each side is of 8 centimeters and each angle is a right angle. Now I have something like this, then I have something like this, and there is a line that I would like to draw, right? This is say A, B, C, D. Mind it, whatever is the area of this part, exact same is the area of this other part. So if I find out the area of this part and double it up, I get the area of my designed part, right? How will I find the area of this part? If from the area of this complete sector, this sector I am talking about, sector you can consider it or a quadrant you can consider it. So from the area of this complete quadrant, I do what? Or let me take this sector. From the area of this quadrant or this sector, when I remove the area of this triangle, what do I get? From the area of this sector, when I remove the area of this triangle, I get the area of this shaded portion, isn't it? What I am saying is, from the area of the sector A, D, C, Q, A, I am removing the area of this triangle A, D, C. I will be getting this shaded portion, right? Area of shaded portion is area of the quadrant ADCQA minus area of the triangle ADC. What is the area of the quadrant? 1/4 of pi r square. So 1/4 of pi r square. What is the radius? If I talk about this as a quadrant, then it is having radius as 8 centimeters because it is the quadrant of a circle of radius 8 centimeters, right? That is what it is representing. So 8 square. This is the area of the quadrant. You subtract area of this triangle. This is a right angle triangle, so this is already a perpendicular. This is the base, this is the height. Base is 8, height is 8. So half into base into height is the area of the triangle. This gives you area of the shaded portion. When you double it up, when you double this area up, you actually get this complete leaf-like designs area, okay? So twice the area of the shaded portion, that means twice of area of the quadrant minus area of triangle, that means twice of this number is actually going to give you the area of the designed portion. So this much centimeter square is the area of the designed portion. So first of all, you find the area of half of this designed portion, this leaf-like designed portion. Half of it you find with the help of what? Area of quadrant minus area of triangle. This gives you the area of half of this leaf-like portion. Double it up, you get the area of this complete leaf-like portion or the designed portion. You can easily compute the value, that's your answer. Let's work towards the next question. In this figure, AB and CD are two diameters of a circle. So please mind it, AB and CD are given as diameters. AB is the diameter, CD is the diameter, O is the center. That means OB is the radius, OC is the radius, OA is the radius, OD is the radius. And it is saying that OD is obviously the diameter of this smaller circle. So the radius, OD is the radius of the bigger circle. This is acting as the diameter of the smaller circle. If OA is 7 centimeters, find the area of the shaded region. The moment OA is given as 7 centimeters, I have already discovered that OA, OB, OC, OD, they are all radii of the larger circle. That means the radius of the larger circle is given to you as 7 centimeters. OC will also be 7, OB will be 7, OA is already given as 7, And if OA, OB, OC all are 7, that means OD is also 7. What will then be, if I say this is the center of OD, the midpoint of OD, say this is M, what will be OM and DM? If this is 7 and M is the midpoint, this is 7 by 2 and this is also 7 by 2. 7 by 2 is the radius of the smaller circle. If 7 is the diameter of the smaller circle, its half is the radius of the smaller circle. So the radius of the larger circle is 7, radius of the smaller circle is 7 by 2. I have to find the area of the shaded portion. What will be the area of the shaded portion? Area of this circle plus area of this shaded portion. So I have area of smaller circle plus area of this shaded portion. How do you write the area of this shaded portion? From the semicircle's area BACB. Let's talk about this semicircle BAC. From the area of this semicircle, when you remove the area of this triangle BAC, what you are left with is this area. So I can write the area of this, only this much portion, as area of the semicircle, area of the semicircle BAC minus area of triangle BAC. So let me write BACB. This is the semicircle minus area of triangle BAC. When from the area of the semicircle BACB I remove the area of the triangle, I am left with this area. In this area, when I add the area of the circle, I get the area of the complete shaded portion in the diagram. What is the area of the smaller circle? It is pi r square. Radius of the smaller circle we discovered as 7 by 2. This is the area of the smaller circle plus area of the semicircle is half of pi r square. Half of pi r square. Now what is the radius to be used? This is the semicircle of the larger circle. BACB is a semicircle of the larger circle, so its radius will be used, which is 7 centimeters. So half of pi r square. This is the area of the semicircle. From this area, you remove the area of the triangle BAC. Area of the triangle BAC, you all know angle in a semicircle is of 90 degrees. This is 90 degrees, right? So this will be the height. OC will be the height, and the moment OC is the height, you know that OB is same as OA. So you have OC as the height and AB as the base. OB is 7, OA is 7, so AB is going to be of 14 centimeters length. So base is of 14 centimeters, height is of 7 centimeters. Half into base into height is the area of this triangle. So it will be half into base is 14, height is 7. From the area of the semicircle, you remove the area of the triangle. This actually, this much portion of the computation is the area of this shaded portion. In that you have added the area of the circle, and that is, this number that you get is actually the area of the complete shaded portion. So this much centimeter square is the answer. Is it clear? That is how you solve questions on areas related to circles. That's it from my side. Thank you.